This is part 2. It already seems to be, it's going to be taking quite a long time. This one's a pretty long video, it looks like. So I've cut out the disclaimer. Essentially, don't be dumb. Don't do what I do. Make sure you do your own research on how to safely do these things. I don't follow safety protocols on almost anything, nor do I even really know what they are a lot of the time. Anyway, we're going to start off here with the cleaning up of sealing surfaces. I go overboard with this. You don't have to go as far as I do, where I'm wire wheeling the surface of where the cover mounts. You don't really even have to go that far. Run it over quick with a razor blade, and when you go to reseal it, just make sure that there's no oil. Oil is the enemy. Excess RTV or whatever on there isn't going to be too big of a deal. Now this is especially overboard. I'm using a sanding disc. A lot of guys are probably going to go off in the comments about how this is terrible for it, because I am sanding some material away. And actually sometimes this is required, actually. Especially when people use a gasket previously. A lot of times they like to wick up water and it causes corrosion between the cover and the case itself, and then you're going to be required to kind of go this overboard. Since we're using RTV to seal it, it really fills in all those gaps. You don't want to go crazy, obviously. If you can, visually see a divot that you've put in there, you've gone too far, but just make sure you don't go that ham. I'm using a worn out 80 grit on this. You could maybe use a 120 to be sure, a little bit more sure that you're not going to end up in that situation. But it's really not that big of a deal. But also, in most cases, not like the case that I'm actually using it here. There's no, it's not required. The better way to do it would actually be using sandpaper. Just a little strip of sandpaper. It's a little bit more time consuming, which is why you won't really see me doing it all that much. There are some times I will, but most times I use that wire wheel. But you can use some sandpaper, some 80 grit is fine. Don't go ham on it, but I imagine you won't be able to just doing it by hand anyway. 120 grit will probably do okay, and then you could even knock it off with some Scotch-Brite. Essentially, we're going to be sealing almost all of this with a layer of RTV as well, so it really doesn't have to be a machined surface anyway. And actually, now that I think about that, a lot of modern cars, most modern cars are coming with RTV already used to seal them. What mechanics figured out 50, 60 years ago, the engineers are only just now coming around to. Should definitely cover that if you do choose to use a wire wheel, especially if you're using it the way I do with that die grinder. It's no matter how much trigger control you have, it's going to spray some wires. You got to make sure to get those out of there. Make sure you clean out that case really nice before putting everything back together. You don't want those things going through the rear. This one's a quick technique for how to clean up the axles or polish them as well. You want to polish the surfaces that the seal rides on, as well as the bearing. Not going crazy. You don't need a mirror finish or nothing, but running some Scotch-Brite through it. I leave it in the axle tubes. Don't do this if you're not planning to replace the seals. You may as well replace the seals, but maybe you don't want to for whatever reason. This is putting pressure on the seals and could ruin them. But since I'm replacing them, it's not a big deal anyway. So what I'm doing is both polishing those surfaces that the seal rides on, as well as where the bearing rides. And then on top of that, a lot of these axles don't have that corrosion ring. I guess this car is kept inside a lot, but a lot of time there'll be a corrosion ring right outside where the seal rides, and when you push that axle in to get the C-clip in, that corroded bit of the axle rides through the seal, which, you know, that's kind of, it's almost like taking sandpaper to the seal. You don't want to do that, right? Obviously. So taking that off is also a good idea. You don't got to get it super perfect polished, and matter of fact, I've even gotten away with not doing it at all. I wouldn't recommend it though. What I'm showing there is actually, honestly, a special tool. Um, I'll think about a way that you could do this without that special tool, but as of right now, I don't have too many ideas. But essentially, it's just gonna be something to press against, but it's also smaller than the diameter of the bearing, so that the bearing can be pressed over top of it as well. This is not actually a professional tool. This is kind of a thing that I guess we sort of fabricombled together to get it done anyway. If you get the professional tools, it's like a clamshell thing. It's got all this stuff kind of already put into the design of how the tool works, and they work great. My pop's actually got one, but I don't work for my pop anymore. Which I guess I should talk about what I am using. This is your normal bearing press. I think that's how they're marketed. Clamping tool that you use in a press. I am not putting it in the press here. Sometimes I have to. Just not doing it right now. And actually, I think both these bearings come off really easy. A lot of times, this isn't enough, and I have to take it over to the bearing tool, though. Or, I'm sorry, the press. So what I do is I tighten it up quick from the top, and that pulls the bearing press up off the neck of below where the bearing actually seats, and then I tighten it up really good. The tighter the better. This will leave burrs on the seating surface of the bearing, the inner race bearing, where the clamshell. Honestly, we should get that clamshell tool. It works great. It actually doesn't do nearly as bad of a job. It does not leave burrs, but this works for us, and so that's what we use. Here is a safety tip that I didn't think about until now, which I'm not using, but one thing you can do is put a rag over that bearing, because a lot of times these things like to pop, and it's hardened metal, so when they pop, they shoot off like a bullet. When they break off a piece of them, it's like a bullet, and it's best. You could just do it with your hand, really, and then at least it's not going to hit your eye. But you put a rag over it, and that's going to keep any of that broken off pieces that shoot off from hitting you in the eye. Also, wear safety glasses. Definitely. I don't, but that's because I'm just, kind of dumb. And the reason I'm not using it is because these bearings are coming off so easy that I can already tell, like I can tell that the tension isn't so high that it's going to actually pop anything, which is a judgment call that honestly also you guys shouldn't be making. Don't do this. It's a bad habit of mine. I know I said that I don't know anything about safety, but really I just kind of ignore it. Oh, I guess I do put a rag on eventually. Now, I know I told you about the burrs that these leave behind, which I don't know if I show like an actual video picture of looking at them or not, but essentially I'm going to grind off a chamfer on the outside of where the bearing seats, which I do on even brand new differentials. I'll still do the same thing. So even if you got the professional tool, whatever, I think this is a good idea, because I've had even brand new differentials come in and there's little bits of burrs on them. So I just do a quick circle around there with a chamfer on, to put a chamfer on that edge. It also it even comes in the directions when you get a gear set. That's how easy it is to get a burr, because a gear set's already totally machined as well, very accurately. But they even tell you to take a file with some sandpaper, and well, you'll see me do that in a future video. I'm sure a lot of you guys are probably worried about, like, But all that metal shavings that you take off with the sandpaper and all that, putting those chamfers on, well, you gotta clean it. You're gonna clean it anyway because, well, if anything went bad in there, you've already got metal shavings all throughout, don't you? So you gotta make sure you clean these things up as well. Now I'm using the press because it's productivity. It's quicker, it's easier, it's nicer. But you can, and I have done used a socket that's just bigger than the surface you're pressing onto, but also not so big that it's essentially you're hitting on the inner race of the bearing, and you can hammer these guys on. It's not really that big of a deal. I have done it. I've done it for my older brother's race car because I was doing it somewhere that was a little bit less equipped. What you do have to be careful about, though, is sometimes these bearings stick out a little bit past the that little bearing mounting surface, and so when you flip it over, you want to make sure you're not going to be damaging the case when you hammer on it or press on it or anything like that. The cage of the bearing, so that piece of metal that holds all the rollers inside. You want to make sure that's a good way to test is to spin the bearing as you go. And if you go and sit it on a surface and you can't spin the bearing, well, then that means that the bearing's contacting before the differential itself, and you don't want that. You don't want to be hitting on that because then you'll damage that bearing cage. Same rules apply here on the pinion bearing where I pull it. I'm going to be using a press, but again, it's not impossible to do it with a hammer. Make sure you protect the threads as you do that, if you were to do it that way. But using that, making sure that you tighten that bearing puller is super important, because essentially what it's doing is it's actually trying to hold those rollers in so that the rollers are pushing up against the top part of that inner race in as equal of a way as possible. And the way it does, when it does that properly, they're all creating an equal pressure on that top lip of the inner bearing race, and everything should. Pinion bearings usually come off pretty easy, but what can happen though is damaging the shim that goes underneath that bearing when you tighten up. I still err on the side of tighten too much, and I think I would still err on that side even if I didn't have 100 shims behind me. We keep a collection of them. I think even if I was doing this at home and didn't have all that resources, I would still err on the side of tighten it as high as possible, because once you bust those rollers off, the only way to get that thing off is essentially cutting it. Sometimes heat can help, but you also want to be really deliberate about heat if you're going to use it, and avoid heat as much as possible, because these things are heat treated very specifically for what they're doing. So you don't want to deliver heat to the pinion itself pretty much ever. Again, I'm using a press, but again, you can also do this with any old pipe you can find that's a good size, and a hammer. It's going to do the same thing. You could probably also do it with a hammer and punch if you're really down bad. I wouldn't recommend that because you can damage bearings with a punch, but it is possible. Now I'm using what is called a bearing and seal driver kit. I believe you can get these for rent off of like AutoZone and Advance Auto. That whole deal where they let you use a tool for some collateral money, and then when you return it, you get your money back. If you can't, I'm pretty sure this is what I saw South Main Auto do. He used some punches. I'd recommend against doing that because a punch can chip these hardened bearings pretty easily, and that, if you had to, you could do it that way. What you'll notice is the sound difference. When you're off center, it's going to sound really solid, but once you're driving that thing in nice and centered, it's going to make a bit of a popping noise, a nice popping noise. I don't think it comes up very well in video, but you will hear the difference. And then as that popping noise goes on, eventually you're going to hit the bottom, and it's going to become super solid at that point, and you'll be able to hear the difference. It won't sound the same in real life as in this video, but it is very noticeable. RTV is your friend when it comes to sealing up a differential. I even use a thin layer on the outside of the pinion seals as well as the axle seals. What I don't show, because I actually didn't use this trick, and I rarely do, but it's definitely better to use it, is on the inside of those seals there's that little spring, and that's to hold tension on the seal lip. Take a little thin layer of wheel bearing grease or something like that, and spread it along that spring. What that's going to do is it's going to help that spring stay put while you try to hammer this seal in, and it essentially just kind of works a bit like a shock absorber, and that's going to be really helpful, because if that spring pops off, it is possible to get it back on using a couple picks, but it's a pain in the ass. I wouldn't recommend having to go through that, especially if you have to be going to be doing this stuff on your back or something like that. I've seen guys go overboard. You don't have to pack the thing tight. Just a nice thin layer over that spring should keep it in place. I always lube the seal surface that rides on the polished metal of whether it be axles or the pinion. You always want to lube these things up. Some of them come with lube already on them. I still put my own on there. That's just me being a little bit overboard. If it's already got lube on there, it's probably fine. I also recommend, as you see, I put the RTV on the splines of the pinion. Not every car will do it, but a lot of times gear oil likes to seep its way through those splines. So I just RTV that. Make sure, well, I can't do it anymore. RTV is great when sealing up a rear end. For pretty much every step. I probably tighten this thing back up way quicker than any amateur should. I'm very used to how these things crush, but I'm telling you right now, once they start crushing, they crush fast. Those crush spacers. and they will bite you. It might not even hurt to have an extra one just in case laying around. I remember the first time I did one of these, my dad told me, be careful tightening it up. Once it starts tightening up, it goes quick. And you know what it is? It started tightening up, and yeah, I over tightened it. Luckily, Ford family, it was an 8.8 and Ford family, so he had like 4 more on the shelf ready to go. But he even told me right before I did it, and I still, messed it up. The point being, be real careful. I can't stress it enough. Maybe let it take you all day. It's not a big deal. Here's a really big example of where my lighting was terrible. You guys didn't see a fucking thing there. I promise you it was in spec, which I'm pretty sure for this is 7.5 inch GM. I'm pretty sure is a 12 to 15 inch pounds. It might be the like a 15 to 19. I'm not actually 100% sure as I'm editing this video. But the definitive specs will be in the description. I want you to pay attention to how I put this differential in. You'll see I get the shims in. Essentially first, I'm using the differential only sort of to hold them in place, but I want to put those shims all the way in before I actually start pressing the differential in. I use a couple hammers. I'll talk about that in a little bit. But I want those shims all the way bottomed out, so that way I don't have to push them in any further once I start hammering that differential, because those shims are cast, and when it's cast, it's very brittle, so you can't really hammer on it. You can get away with a little bit if you have to. You maybe realize, oh, I didn't have it in quite enough, and just very light taps. Maybe the differential's not in there quite all that deep, so it's not under too much tension. You can get away with it sometimes, but ultimately I would recommend making sure those shims are in all the way before you start really pushing that differential in. Now, as far as the hammer thing goes, essentially all I'm doing is using that middle hammer as a bit of a shock absorber so that it doesn't really hit that bearing hard. It's more of a push rather than a strike. That keeps it from chipping the bearing. I know a lot of guys are probably going to be like, I've seen the Mythbusters episode too, where they think that hitting a hammer with a hammer is going to cause chips to fly everywhere. It's going to hit your eye. Maybe there's some truth to it. I don't know, but I've been doing it for years and have not had a single issue with that. But that's up to you guys to decide on what's safe to do and what's not. You can find your own safe ways of doing the same thing.